Hi everyone, welcome to a new video. In this video, we'll learn how to use Cramer's rule to solve a system with three variables. Cramer's rule will give us the solution in terms of the determinant. And for a system with three variables, we will be using 3 by 3 determinant. So let's see how to apply the Cramer's rule for a system with three variables. Let's illustrate this with an example. So let's say we have the following system. X plus 2y plus z equal to 2. X plus y plus 2z equal to 1 and x plus z equal to 3. Now to use the Cramer's rule, make sure that the variables are written on the same order. So for example, the first equation we have x, then y, then z. In the second equation, they should be also in the same order, and in third, they should be in the same order. If you have one which is not in the same order, reorder the variables. The third equation, we don't have y here, so it means the coefficient of y is actually 0. So this is like x plus 0 times y plus z. So the solution using Cramer's rules will be as follows. The value of x will be dx by d, and y will be dy by d, and z will be dz by d, dx, dy, dz are all of them determinants. So essentially, once you compute the determinant, you can easily just plug in to get the value of x and y. So let's start first with the determinant d. And d, we can get it simply by using the coefficient of the variable. The coefficient for the system are 1, 2, and 1. And then we have 1, 1, and 2. And then you have 1. Notice y is absent, but you should write its coefficient, which is 0, and then you have 1. So this is d. We can evaluate this one. There is a trick to do this. There is a video on the channel to teach you this trick, so I'm going to use that trick. You need just to copy the first two columns to the right. So I'm copying the two columns. And then we'll form the positive diagonal multiples. So the first positive diagonal will start with 1 and going this way. So this is plus. The second one will start from 2 going this way. This is plus also. And then this one. So these are the plus. We have also negative diagonals. So this starting from the lower element here and going this way. And then from 0 going this way. And then from 1 going this way. So these are negative. So then d is equal, the first positive diagonal 1 times 1 times 1, that is 1. The second positive diagonal 2 times 2 times 1, that give you 4. The third one 1 times 1 times 0, that give you 0. Negative diagonals 1 times 2, 1 times 1, 1. And then the second one 0 times 2 times 1, that is 0. And then 1 times 1 times 2 give us 2. So d will be 1 plus 4, 5, and then minus 1, 4, minus 2 give us 2. So that's the value of d. Now we can also compute the value of dx. How are we going to do that? So dx is simply the same as d. It's exactly the same, except we're gonna replace the coefficient of x with the constant coefficient. So the coefficient of x are 1, 1, 1. We're gonna replace them with the constant coefficient, so it will be 2, 1, 3. The other element remain the same, so you get 2, 1, 0, and then you have 1, 2, 1. Again, I'm gonna use that trick to compute this. So the trick simply work as follow. So we're gonna copy the first two columns. And then we're gonna form the positive diagonals. So this is 1. This is the second. And this is the third. So all of these will have a positive sign. And then we have also negative diagonals, starting with the lower element here. Negative. Again, this is explained in detail, this trick, in another video. You can watch that video to learn about this trick. So dx, you multiplying the positive diagonals, 2 times 1 times 1 give us 2, plus 2 times 2 times 3 give us 12, and 1 times 1 times 0 give us 0. Negative now diagonals, 3 times 1 times 1 give us minus 3, and 0 times 2 times 2, that is 0. and then 1 times 1 times 2, that give us 2. So here 2 plus 12, 14 minus 3 give us 11, minus 2 give us 9. So then x, you can easily calculate x, which is dx over d. dx is 9 and d is 2. So this is the value of x. Now to calculate y, we need to find dy. So how we're gonna find dy? Again, we start with d and we're gonna replace the value of the y coefficient with the constant coefficient. So the x coefficient remain the same. Then we replace the y coefficient. The y coefficient are 2, 1, 0. Now we're gonna replace them with the constant coefficient, which is 2, 1, 3. The coefficient remain the same. Again, let's use a strict to find the determinant. Let's copy the first two columns. And then let's form the positive diagonals. So this is plus, this is plus, and this is plus. And we have negative diagonals. So dy is equal to first positive diagonal 1 times 1 times 1, that is 1, plus 2 times 2 times 1, that give you 4. The third positive diagonal 1 times 1 times 3 give us 3. Let's now move to the negative diagonal, minus 1 times 1 times 1, that's 1, minus 3 times 2 times 1 give us minus 6, and then last one, minus 1 times 1 times 2, that is 2. So 1 plus 4 plus 3 give us 8, minus 1, 7, minus 6, 1, minus 2 give us minus 1. And so y is simply dy over d. dy we just computed as minus 1, and we computed d before, which is 2. So this is the value of y. Now we can also compute dz the same way. So the determinant dz is the same as d, except that we are replacing the coefficient of z with the constant coefficient. So then x coefficient remain the same, y coefficient remain the same, and the z coefficient will be now replaced with the constant coefficient. So this is the determinant. Now to evaluate this, let's use the same trick again. Let's copy the first two columns. And positive diagonal, this is the first positive diagonal, second and third positive diagonal, negative diagonals, so dz equal to first positive diagonal 1 times 1 times 3 give us 3, second one 2 times 1 times 1 give us 2, third one 2 times 1 times 0 0. Now negative diagonal, minus 1 times 1 times 2 give us 2, 0 times 1 times 1 give us 0, 3 times 1 times 2 give us minus 6. So here 3 plus 2 5, minus 2 give us 3, minus 6 give us minus 3. So then z is dz over d. dz here is minus 3, we just find it out, and d is 2. So that is the value of z. So this is how to use Cramer's law to solve a system with 3 variables. So that's it for this video. If you find this video useful, please give it a like and consider subscribing to the channel and turn the notification on so that you get notified about new content. Thank you for watching.